Hello guys, hope you are all okay. Anyway, we have a chip that generates the 5 volts and the 3.3 volts always. All right, reason why I'm showing you this again, I'm pretty sure you are irritated now because you've been learning about the chip that generates the 3.3 and the 5 volts always. Anyway, I want to show you something. Okay, this is this is the structure on the schematic. There will be a chip in the center, and then on the left hand side, this is where the 3.3 volts always is generated. You'll see those two MOSFETs and the coil, and on the right hand side is where the 5 volts always is being generated, and you'll see two coils, one connected on the main 19 volts and the other one connected to ground. And you'll have what? You'll have a coil there, an output coil there. Let me show you this thing in real life. So in real life, it's gonna look like this. I'm pretty sure now you are confused because it's not the chip, it's not in the center. This is the chip, all right. And then you have a coil, two coils there. One coil is for 3.3 and the other one is for 5 volts. Let's have a look at it in the schematic. This is how it looks in the schematic, and then this is how it looks in real life. But again, it won't be like this. They can put them in any shape, in any stance as well, but you have to be able to identify them. You have to be able to see that this is the 3.3 and this is the 5 volts. I'm sure you can see, right? And you can see that these power rails here, these ones here, I mean this last MOSFETs here, I'm pretty sure, 100% sure they are connected to 19 volts. You can see the plus sign here. This means this is the main power rail. You can see how big it is. This is the 19 volts, and the other two are connecting on the coil, and the other side of them is connecting to ground. And you can see the gates. You can see the gates, and one side is what? It's ground. All right. Anyway, don't panic, guys. This is the coil in real life, and there it is, a coil, a road wire. Inside there's a road wire. Inside this thing there's a road wire. This is a coil. Coils, they are inductors. They are well known for inducing the power, and they create magnetic field to remove the spikes. Because when these two guys switch on and off, there will be a big spike of 3.3 and a big spike of 5 volts. So we need coils to rectify everything, and we need coils to give power to that 3.3 or to that 5 volts. Coils induce the power, and they remove spikes as well. And there it is. This is the chip generating the entire thing. How the chip controls the gates. That's what it does. It controls the gates of these 4 MOSFETs. Let's go back. Let's check this one, the first one. You can see pin number 4. Let's go straight to pin number 5 on the chip as U gate 2. It means upper gate 2. Okay, why the 2? It means it's the second power rail, of which is 3.3 volts. And let's check another more gate here. L gate. It means it's lower gate, but the chip connected to where? To ground. And again, one thing I like about chips, they want the feedback. As you can see here, if you follow my cursor, you will see. Let's follow my hands, you will see. Go straight here as FB2 means it's feedback, and FB1 is feedback 1 for the power rail 1, of which is 5 volts. It needs to know how much power it is generating, and see if it is accurate. Okay, if something's wrong, the chip will shut down. Because of the feedback, they can sense everything. The feedback FB1, and 3 means enable, and 3 means enable. And this one TONSL means time on, ref, and then NC not connection, not connected, voltage regulator, V in ground, skip cell, enable, lower gate. I've explained as I've explained, and then chip, they will have this boost puts, and they will have this voltage out, and then voltage out 1. All right. Voltage out, they're also connected to ground, I mean to feedback, because it is the main power. It is the out, it is the power that is being generated by the entire thing. So it's volt out. So obviously they are connected where? To a feedback. This is it in real life, so you'll have to be smart. Use those resistors to check for time on, check for feedback, check all those things, because the chip is so tiny. If you use your big probe multimeter, you'll end up shorting some other things. So that's why I suggest that you check through those capacitors around, right around the chip. Anyway, this is it. I like to have these short sessions. Let me end it here, guys. I love you so much. I'm gonna see you next time. Bye bye.